Hello, so today we are talking about transforming discrete random variables. So transforming is going to be a review of chapter 2 and how we can transform variables by either adding a constant a or multiplying by a constant b. So this is in section 6.2 of your textbook. Please look there for more examples and practice as we go throughout this unit. So let's take a look at example 1. This example is the same example that we were working with in the last video on socks for random variables. So let's just review it again. It says Linda sells cars at a large auto dealership. She motivates herself by using probability to estimate her sales. And we said that X is the number of cars she sells, or the number of cars sold. So we made this probability distribution. This probability distribution has all of the x's, our discrete random variables, or my x's are my countable outcomes, and then they match up with their probability, or p of x. So last video we found the expected number and standard deviation of this probability distribution. We got the expected value to be 1.1 cars. The variance, we used this really long formula and got the variance to be 0.89. When I took the square root of that, I got my standard deviation of 0.943. So this is review, but we're going to use these numbers today when we start applying the principles of transforming random variables. So the first way we can transform random variables that we're going to look at is transforming the mean. So the mean is what we're transforming first, and we start out with if x is a random variable and a and b are fixed numbers, then my new expected value, or the transformed expected value, equals the constant a plus b times the current expected value. So make sure you get down this formula. All the formulas that we see today are going to be super important, so make sure you get this formula down. So let's apply this formula to Linda and her cars. So if we build on our previous example, it says, suppose Linda earns $300 for every car she sells. On average, how much money can she expect to earn a day? So what signals to me that I want the mean is it says on average and expect to earn. This is looking for my expected value or my transformed mean. Well, in this equation, I have an A and a B. If you think back to chapter 2, we said that A was my fixed value, or A was my constant, and B is my multiple. Well, if I think about this problem, does it say I get $300 and then I'm done? Or does it say it's $300 for every X that we have? Well, this is saying $300 for each car, so $300 is going to be my B, or the multiple that I multiply my expected value by. So if I think about the other parts of my equation that I'm kind of missing, this mu of x, well, this comes from my old expected value, and we see on the other slide that mu of x was 1.1 cars. So I have my b is 300, and my old mean is 1.1, so all I have to say is my new mean is 300 times my old mean. This is b, and this is mu of x. And when I do that, I get that my new expected value is $330. If I have to interpret that, I would say Linda can expect to earn $330 each day. So this was one example. If I look at my second example, it says if Linda earns a daily rate of $100 and then $250 for each car she sells, what would be her expected amount of earnings for each day? Well, now I have a B and an A. If I think about this problem, a daily rate of $100, that would give me A of 100, or a constant, a fixed value of 100, and B would be 250. And then like the last problem, my mu of x comes from my probability distribution that we found last video as 1.1. So now in example 1b, her new expected value would be A, or 100, plus 250, which is B times my old mean of 1.1. And when I do that in my calculator, I get her new expected amount of money each day would be $375. So this could be an example of maybe a kind of think about it problem. Which deal is better? Should she get $300 for each car she sells, or $250 for each car she sells with this daily rate of 100? And you can use this formula to help you compare those two examples and see which deal is better. And in this case, example 1b is better. She makes $375 as opposed to just $330. So key point number 1, when we add a constant, the mean is increased by that number. When we multiply by a constant, the mean also gets multiplied by that number. And if we think about chapter 2, this is the same key point. The center changes by both A and B. Now the variance and standard deviation are a little bit different. So the variance, we said, is the standard deviation squared. So if x is a random variable and A and B are fixed numbers, then my variance that's transformed is B squared times the variance. So A has no impact on my variance, it's only B that does. Well, B squared times my variance makes sense because both of those are squared. But if I'm dealing with my standard deviation that's not squared, I'm just going to use the absolute value of B because we cannot have a negative standard deviation. So B has to be positive when we multiply it by the standard deviation. So let's take a look at these in practice. It says, Linda earns $300 for every car she sells. What would be the standard deviation of her daily earnings? Well, we said $300 for every car she sells. That means B is 300. And the standard deviation from the last example, if you look back at the beginning of this video, is 0.943. So if I think about my new standard deviation, that would be 300. I can write just 300 since it's positive, times my standard deviation of 0.493. So my new standard deviation is a lot bigger than it was. Now it's 282.9. So that makes sense because now I'm talking about money, and money is going to have a much bigger spread than cars. So your standard deviation may jump up a lot, and that's okay. That's normal. So don't freak out if it's huge. The variance, it doesn't ask about this, but if I did need to find the variance, it would be 300 squared times my variance of 0.89. And when I do that, it's going to be an even bigger number. It's going to be a variance of 80100, or 80,100. So you may get some big numbers in these problems. That's why I'm showing you that this variance could be $80,000 or $80,100, and that's okay. Example 1b says if Linda earns a daily rate of $100 and then $200 for each car she sells, what will the standard deviation be? Well, we said daily rate, that's my A, so A is 100, B is 250, and then the old standard deviation was 0.943. Well, if I think about how this is going to change, does A impact my standard deviation? Does A change my standard deviation at all? No. A doesn't do anything to my standard deviation. Only my B, or my constant that's multiplied by the standard deviation, changes it. So, my new standard deviation would be 250 times 0.943, and that gives me $235.75. So her spread, Linda selling cars, the spread of her distribution, for example B, or this second option, is smaller than her spread for example A. Remember, standard deviation measures spread. And like we remember from chapter 2, the spread only changes by multiplying by B. So spread only changes from B. When I add a constant, the standard deviation does not change. But when I multiply, the standard deviation also gets multiplied. So that's a wrap. We transform random variables by multiplying by a number B or adding a constant A. Once again, this is section 6.2 in your textbook. There's plenty more examples and practice there if you want to see another one worked out. Thanks, and I'll see you next time.